In the previous part, we saw that the effect of logging a number is that it makes it smaller, or we could say it compresses it. And this compression occurs more for the bigger numbers than for the smaller numbers. So for instance here, 120 gets scaled back all the way to 2.08, when 30 gets scaled back to 1.48. So the log transformation has a bigger effect on the bigger numbers than it does on the smaller values. They all shrink, but the bigger numbers shrink more. Okay, let's now see this in a graph form. So here we've got a log x transformation. So we're compressing our x values here. So it compresses the upper end of the x values. So this is the important thing. It's compressing the upper end to the bigger values of the x scale here. So x values undergo a log transformation, the y values remain the same, and it's used for relationships that look slightly exponential. So let's now look here, and as you can see, we've got data that kind of bends here. So what we want to do is we want to take these large x values and we want to compress them so that it becomes more linear. They're all going to be compressed. All the x values are going to be compressed, but these bigger ones are going to have a bigger compression, as we've seen up here. So to over here, if we've got a graph that looks like this, we want to take these x values here and we want to compress them to make a more linear line going on there. So that's visually what's happening when we're applying a log x transformation.